Hi everybody! In this video I explain to you the 3x+1 maze. The 3x+1 maze shows patterns within the 3x+1 problem. And you can find more information on this problem and also about the 3x+1 maze in the description and also in my book with the same title, the 3x+1 maze, which you can find on Google Books. Its link is in the description as well. Okay, so the 3x+1 maze consists of a center and an unlimited number of circles which are connected to each other. And we're going to walk through these circles starting from the center. So that's where we start. And how can we walk through the 3x+1 maze? We either go to the next circle or we go counterclockwise. For example, we go to the first circle, then counterclockwise, to the next circle, counterclockwise, counterclockwise, and then to the third circle, and then we choose to directly leave the circle, just as an example. Okay. So what does this tell us? Well, we'll show this example again, and we add to this that we have thin pads and thick pads. And a thin pad represents a 0, and a thick pad represents a 1. So we'll keep track of our thin pads and thick pads as 0s and 1s. So let's show the same example again. We start in the center, first a thick pad to get to the first circle, then a thin pad, then a thin pad going to the second circle, thin pad, thick pad, so a 1, and then a thin pad, so a 0. And then in the third circle we directly leave on a thick pad, so that's a 1. So we have these 1s and 0s, and the value of these digits doubles. 1, 2, 4, 8, 16, and so on. Powers of 2. So we have 1, 1, 0 of 2, 4, and 8. So that's just 0, 1 of 16, and 1 of 64. So that adds up to 64 plus 16 plus 1 is 81. So 1, 0, 1, 0, 0, 0, 1 is the binary representation of 81. And in the 3x+1 problem, the 3x+1 problem, we do the following. If we have an even number, we divide by 2. And if we have an odd number, we multiply by 3 and we add 1. 81 is odd, so we multiply by 3 and we add 1, which is 244, which is even divided by 2, 122. And so we reach the odd number 61. And then we continue. 61 is odd, so times 3 plus 1. And here we see what happens through the even numbers 184, 92, and 46. We reach the odd number 23. 23 is odd again. Times 3 is 69 plus 1, 70. Divided by 2, because 70 is even, is 35. And now we look how many even numbers do we have between the odd numbers, starting from 81. And what do we see? We have 2 even numbers between 81 and 61, which is exactly the numbers of visited nodes in the first circle. Between 61 and 23, exactly 3 even numbers, the number of nodes visited in the second circle, and we only visited 1 node in the third circle, which is exactly the 1 even number between 23 and 35. Cool. And this works for every walk through the 3x+1 maze. So let me give you a second example. This time we're not picking a walk, but we say, okay, let's visit 3 nodes in the first circle, 4 in the second, and 2 in the third. And then we start walking. Okay, we start in the center, go to the first circle, a 1, thin line 0, thick line 1, and we keep on going, visiting the same node again before leaving the first circle. So we visited 3 in the first circle, now 4 in the second, thin line, so 0, thin line, so another 0, leaving after 2 nodes in the third circle, thin line, another 0. So many zeros this time, and the 1s add up to 8 plus 4 plus 1 is 13. So here we have the number 13. And then again, even divide by 2, odd number times 3 and plus 1 So 13 times 3 plus 1, 39, 40. And then even 20, 10, 5 is the next odd number. Exactly 3 even numbers between 13 and 5, which is the number of nodes visited in the first circle. Then 5 times 3 plus 1 is 16, brings us to 8 for 2 before reaching the odd number 1. Exactly 4 even numbers, the number of nodes in the second circle. And 1 reaches itself after reaching 4 and 2 first, 2 even numbers, exactly the number of nodes in the third circle. So here we see it works again. We give a third example, and that will be our final example. And this time we pick a starting number, 461. And 461 is equal to these powers of 2. So that gives us the binary representation, which equals 461. And this binary representation, written from right to left, gives 1, 0, 2 ones, 2 zeros, and then 3 ones, which corresponds to a thick pad, 1 thin pad, 2 thick pads, 2 thin pads, and 3 thick pads. So we start our walk again from the center with 1 thick pad. There we go, 1 thin pad, then 2 thick pads, then 2 thin pads, and then 3 thick pads. 1, 2, and 3. And we see we reached 3 nodes. In the first circle, 3 also in the second, and 2 in the third. And now we will show 461 again when we do divide by 2 if we have an even number, times 3 and plus 1 for an odd number. And what do we see? 461, exactly 3 even numbers before reaching the odd number 173. 173 also reaches 3 even numbers before reaching the odd number 65, and 65 reaches 2 even numbers before reaching the odd number 49. 332, exactly the number of visited nodes in the first, second, and third circle. So this is how the 3x plus 1 maze works. All our examples were in the 3x plus 1 maze with 3 circles, but you can add more circles. For example, this is the maze with 4 circles. And you can try examples yourself with 4 circles, or just stick to 3 circles, whatever you prefer. If you want to know why the 3x plus 1 maze works, you can read it in my book. And if you're interested in getting to know the 3x plus 1 problem or doing some research on your own, I can also recommend very objectively my own book as a good starting point with your own research or curiosity, whatever it is. Okay, so, So thank you for watching.